Okay, we could go ahead and plot out all the points. So sine of 0 is 0, sine of pi on 4 is 1 on root 2, sine of 90 degrees is 1, sine of pi is 0, 3 pi on 2 is -1, 2 pi is 0. What we find is they all repeat themselves, we know that. So let's instead concentrate on what our basic shape is, up to 4 pi. And back to minus pi. So what we find is that's 0. There's 2 pi where we get back to the start again. And even if I go over that in a different color, we can see that the graph repeats itself. Okay, 0, 2 pi, 4 pi. That's -2 pi there, which makes that -pi there. That one's pi, 3 pi. And the good thing about our trig graphs is that everything's symmetrical. So that point there is halfway. So that's pi on 2. That's halfway. There's 3 pi on 2. Okay. So, and we can see just down here in the bottom corner, that's what our standard sine graph looks like. For what we call, so the features, let's talk about the features. The maximum value and the minimum value for any sine or cosine graph are 1 and -1. Okay, so that's the highest and the lowest. Because don't forget, we've got a unit circle here that we're talking about, and the furthest we can be from the origin is of length 1, or -1 for that matter. -1 down there, +1 up there. +1 at 90 degrees, which is there. -1 at 270, which is there. So the graph repeats itself every 2 pi units. Okay, that is called the period of the function. So what we're going to say is this graph has a period of 2 pi. That's how long it takes to repeat itself. All right. The maximum minimum values we've spoken about at +1 and -1. And the distance, the other terminology we use is the distance from the middle point. And the middle point is our average value. It's that line there. It's where the axis is. It's the mean position. So the distance from the middle point to the extreme points, whether it's the top or the bottom, is called the amplitude. And the amplitude of my sine graph is 1. So the key to remember is the amplitude just tells you the distance. So there's no such thing as a negative amplitude. All right. So my period is 2 pi. My amplitude is equal to 1. All right. They're the two key features of my sine and cosine graphs. All right. If we go on to the cosine graph, it can be drawn in a similar way. The only difference is, look at the starting point. It starts slightly differently. So I could, if I wanted to, if I just got here, if I just did that part of the graph in blue, that's exactly the same as the sine graph, isn't it? Okay, so the sine and cosine graphs have exactly the same shapes, they just have different starting points. All right, so again, minimum -1, maximum +1. Let's just get rid of what I just drew. Oop. Get rid of that stuff there. And it takes 2 pi again to start repeating. So there it is. We'll start repeating it. There. Repeat another cycle. Okay. That's why we call them periodic functions, because they repeat. All right. So for our sine and cosine functions, value at the front is A, my amplitude. All right. The value in here, that's a dilation factor, and it affects my period. All right. We'll spend more time on these. K value, we've seen this before, moves the graph up and down, and inside the bracket we move left and right. Okay. So the key things here are The amplitude is the number out the front, so the A value, and X, my period is given by 2 pi on whatever the n value happens to be. All right, so very quickly, if we want to state the amplitude and period of all of these examples, let's go amplitude. So the amplitude is 3. The number there is actually a 1. So the period is 2 pi on 1, which is 2 pi. Amplitude is equal to 0.5. The period is equal to 2 pi on 4, which is equal to pi on 2. Amplitude is equal to a half. The number in front of the x there is a half. So the period is equal to 2 pi on 1/2, which is equal to 4 pi, right? 2 divided by a half is 4. Amplitude is equal to 2.5. Period is equal to 2 pi on n, which is 3. Amplitude is equal to a half. Period is equal to 2 pi on, number in front of the x is a quarter, which is 8 pi. Again, amplitude is equal to 4. Period is equal to 2 pi, number in front of the x is 2, which makes the period pi. Amplitude, no number out the front, so it's just a 1. Okay, so we want to do our graph sketching. So looking at the graphs here, we want to sketch the graph of each of the following and state the amplitude and period. We're given a domain, we need to sketch it over, okay, which is 0 to 360. So straight away for this one, I'll probably notice a little, I won't say it's a mistake, but my axes are labeled in radians and not degrees. So really I should have them in degrees. So first things first, whenever we sketch a trig function, we identify, probably guess it, the period and the amplitude. So the amplitude is equal to 3. The period is equal to 2 pi on 2, which is equal to pi. Now I'm going to sketch it two ways here. I'll sketch it initially the way in which I would like the way in which you can sketch it in your books. At this point in time, all we need to do is, we know we've got a sine graph. So the sine graph starts at the origin, goes up, comes down to there, and then repeats itself. So you do that first cycle. The maximum value is the amplitude, which is 3. The minimum value there is -3. That point there is the value of my period. All right. So in this case, I better rub that bit out because my period is pi, which if you like is, I guess what I should have written in here is I've written 360 over 2, which is 180 degrees. So that's 180 degrees, that's 90. All right. So I now need to do another period or another cycle, and that also takes 180 degrees to get done. So that's 360 degrees there, which means that one there is 270. All right. So without necessarily worrying about labeling my grid first, I can sketch the graph. Well, actually, I'm going to have to make a couple of changes here. Let's turn that into a 3 and that into a -3, eh? So I know that my graph takes 90 degrees to get from start the first half of the cycle. So it's going to go up and down in 90 degrees, around and back to the start again by pi units. So there's one cycle. So the first half's not great. So up and down and back by 2 pi, or 360 degrees. All right, so that's all we're looking to do. You just sketch one cycle first. So if I come into the second one, period is equal to 2 pi on n, which is 3 in this case, and the amplitude is equal to 2. So again, if I just had to do a quick sketch here, my cosine graph starts up here and then comes around, and that point there is whatever value the period is, which in this case is 2 pi on 3, which means that point there is pi on 3. A half of pi on 3 is pi on 6, and that one there is 1 pi on 6, 2 pi on 6, that one there must be 3 pi on 6. And that's up at +2, and that's at -2. So that's all you need to have in your books. Okay. For me, the grid's probably a bit tight if I try to do it on the main one. So it starts at 2, and at pi on 3, I'm finished, and then I'm back up here again by 2 pi on 3. So really, I'm going to go, all the way down to -2 and all the way up to there. And then if I had to repeat it for another 2 pi, I'm back down there and I'm back down here. So I've got to go down, up to there. All right. So the question's not asking for these ones, but if you had to sketch multiple cycles to there, and the key thing to note is the distance from there to there is 2 pi on 3. The distance from that point to that point is 2 pi on 3. The distance from that point to that point is 2 pi on 3. So the distance between all your corresponding points are 2 pi on 3, or whatever the period happens to be. So let's have a look at our final one. Again, they're not very good axes. I'll fix that for next year. We've got between 0 and 2 pi, 2 sine pi t. So again, amplitude is equal to 2, period is equal to 2 pi on whatever n is, which is pi, which is equal to 2. So again, between 0 and 2, I've got to sketch the graph. It's a sine graph, so it starts here. I'm just going to do one cycle initially, put in all my key values, +2, -2, and the value here is whatever the amplitude, the period happens to be, which is 2. So that's 2 there, which means that point there must be 1. That point there is a half. That point there is 3 on 2. Now I only needed to do between 0 and 2 pi, so that's as far as I need to go. All right. So we don't have to bog ourselves down with finding. Notice I didn't worry about trying to find all these intercepts. Sometimes they might work out nicely for us, but it's just drawing one cycle and then fill in some values. Okay. I was able to find these intercepts here without really doing anything. I just knew it was half, a quarter, etc., etc. All right. See how you go. Lots of practice.